In this video, we're covering the laws of logarithms. And before any of them make sense, you need one sentence. A logarithm is a power. That's it. That's the whole topic. Look at these two. Those say the same thing. 2 cubed is 8. And log base 2 of 8 is 3. Read the second one out loud as a question. What power do I raise 2 to get 8? 3. The log is the power. Every time you see a log, that's what it's asking. And now look at this. On the left, the 3 laws of exponents from the very first video. On the right, the 3 laws of logarithms. They're not 2 sets of rules. They're one set, seen from 2 sides. Multiplying becomes adding. Dividing becomes subtracting. And a power becomes a multiplier. If you already know the exponent laws, you already know these. So here's the definition. Log base b of x equals y means b to the power y equals x. The base is the number doing the work. The argument is where you're trying to end up. And the answer is the power itself. Say it as a question every single time. What power do I raise the base to get the argument? Log base 2 of 8 is 3, because 2 cubed is 8. Log base 10 of 1,000 is 3, because 10 cubed is 1,000. Log base 5 of 25 is 2. And log base 9 of 3 is a half, because the square root of 9 is 3. 2 of those are worth saying out loud. If there's no base written, just log, it means base 10. And if you see ln, that's log base e, the natural log. Exam papers switch between them without telling you, so read the base first, every time. Now the 3 laws. Log a plus log b is log of a times b. Log a minus log b is log of a over b. And log of a to the n is n times log a. The power comes out the front and becomes a multiplier. Then 2 freebies. Log of 1 is always 0, whatever the base, because anything to the power 0 is 1. And log of the base itself is always 1. And last, change of base. Log base a of x is log base b of x over log base b of a. And that b can be anything you like, which in practice means whatever your calculator has. Example 1. Evaluate log base 3 of 81 without a calculator. Ask the question, what power of 3 gives 81? 3 to the 4th is 81, so the answer is 4. Now this one, log base 2 of 1/8. What power of 2 gives 1/8? 2 to the minus 3, so the answer is minus 3. A negative answer just means the argument is below 1. Nothing has gone wrong. Example 2. Condense this into a single log. 2 log 3 plus log 2. Deal with the coefficient first. The power rule runs backwards, so 2 log 3 is log of 3 squared, which is log 9. Now the product rule. Log 9 plus log 2 is log of 9 times 2. Log 18. Coefficients first, then combine, every time. Example 3. Now the other direction. Expand log of x cubed, y, over z squared. The division becomes a minus, so that's log of x cubed y minus log of z squared. Then the multiplication becomes a plus, log x cubed plus log y minus log z squared. And finally, the powers come out the front. 3 log x plus log y minus 2 log z. Watch that minus. It attaches to the 2 log z and nothing else. Example 4. And this is the one everybody gets wrong. Log of a plus b is not log a plus log b. There is no law for the log of a sum. Watch what happens with numbers. Log of 2 plus 8 is log of 10, which is 1, But log₂ plus log�8 is log of 16, which is 1.204. Those are not equal, and they're not even close. Addition inside the log stays stuck inside. The product rule turns addition outside into multiplication inside. That's the opposite direction. Last one. Evaluate log base 5 of 100. Most calculators only do base 10 and base e, so we change the base. Log base 5 of 100 is log 100 over log 5. That's 2 over 0.699, 2.861. Now check the size before you trust it. 5 squared is 25, and 5 cubed is 125. So the answer has to sit between 2 and 3, and it does. Put 5 to the 2.861 into your calculator, and you get 99.94. Not exactly 100, because 2.861 is the rounded answer, not the exact one. So the laws of logs are the laws of exponents wearing a different coat. And the reason we bother with them is coming up next. Logs are how you get a variable down out of an exponent. Next video, solving exponential equations.